let's solve this equation for the interval between 0 and 2 pi, inclusive of 0, not inclusive of 2 pi. Mm-hmm. So the trick with this one is that you've got a double argument right there. You have a double angle inside there, and that makes it a little bit tricky. Now, there's a couple ways to do it. If you already know the property, there's a property for sine of 2x. Have you seen that before? Mm-hmm. And actually, you are going to have to use that double angle formula. So this is equal to 2 sine x cosine x. The sine of 2x is equal to that. So I'm rewriting that part of it. So that was rewritten. And now I can factor out a sine x from both of those. So taking a sine x out, there will be a 1 left there. Don't forget that. And there will be 2 cosine x left here. Equals 0. Now, anytime you get a product, see how this is a product now that equals 0?
Is it? I thought it wasn't 2 cosine. I thought it was just
it is going to be 2 cosine because I took the sine x out.
I see. So therefore.
So there's a 2 cosine left here, and there's a 1 left here.
Gotcha.
When I factor it out, it's like reverse distributing. Follow how I did that? Now, you might wonder, why would I want to do that?
But I'm just confused. Why wouldn't it be plus?
So let me explain this in this way. If I had x plus 2xy, how would I factor an x out?
You take the x out, and then
I'd have 1 plus 2y. I don't have x squared. I have just 1x. So again, those are things that a lot of people, this algebra, like algebra 2 stuff, but it's easy to forget the rules for that. And if you ever can't remember, I recommend just doing like what I did down at the bottom. Like prove to yourself that you can or can't do it. Okay, now that I've done that, I'm going to use the zero product property, because if something times something else equals 0, what's the only way you can make something times something else equals 0?
A equals 0, B equals 0.
Either A has to be 0 or B has to be 0, and it doesn't matter what the other one is. If one of them is 0, then the product is 0. That's the power of factoring, because factoring gives us, see how we had 2 terms here? Set equal to 0, that means nothing. If I have 2 factors, set equal to 0, then I can say either sine x has to be 0 or 1 plus 2 cosine x has to be 0. And that's the zero product property, algebra 1. Factoring with quadratics, it turned your quadratic, which had 2 factors in it, into a product of factors. That was the whole point behind factoring when you were doing algebra 1 second semester. And now I can solve each of these by looking at my unit circle. Where's the sine equal to 0? The sine is equal to 0 at, remember, that's your your y coordinate rather. So it's your y coordinate.
Yes, it's pi.
At pi. I'm sorry, at 0 and at pi.
Yeah.
Right?
And at 2 pi.
But we're not going to include 2 pi, right?
So
x is at 0 and at pi. And then now let's solve this one. Where does the cosine x equal negative 1/2? Notice I did that all at once.
That's
2 pi over 3 and 4 pi over 3.
Was it negative 1/2?
Pi over 3.
Cosine is here.
Oh, it's negative, so 2 pi over 3 and then 4 pi over 3.
That's right. 2 pi over 3 and 4 pi over 3. 2 pi over 3 and 4 pi over 3. And then the last step is to make sure that you've answered the question right and there aren't any extraneous solutions, because sometimes with this you get a solution and you look at it and you realize, oh, no, that can't go into the original. So it's good to check them generally, and I always recommend using the store button on your graphing calculator if you have that feature. Literally store each one of these values in for x and then type this expression in and see if it equals 0.
Been allowing us the calculator for
It's always a good idea to do that, though,
Gotcha.
because teachers on the ACT, SAT, you're allowed to use a calculator, so learn how to use it and learn how to check your answers that way.